In this video, we will cover the 4 ways to represent a function. The 4 ways to represent a function are as follows. 1. With an equation. 2. With a table. 3. With a graph. And 4. Using words. Let's start with the first case. Consider the equation y equals x squared. Before going any further, let's verify that this equation actually represents a function. Remember, the definition of a function states that for every input, there will be exactly one output, obtained by following the rule of the function. The rule here says to take an input value x and square it to obtain the output value y. Through an examination of the equation, we can see that no matter which value of x we choose to input, only a single value of y will be obtained as an output. For example, an input of 5 will obtain an output of 25. An input of 7 will obtain an output of 49, and an input of 12 will obtain an output of 144. Thus, we can confidently state that the equation y equals x squared actually represents a function. Now, let's move on to the second case, a table. To represent the function y equals x squared with a table, we'll start with 2 columns like so, labeling one as x and the other as y. Next, we must choose some x values, or input values. Let's use the integers from -2 to 2. To obtain the y values, or the output values, we must take the input values and follow the rule of the function. For an input of -2, we obtain an output of 4. For an input of -1, we obtain an output of 1. For an input of 0, we obtain an output of 0. For an input of 1, we obtain an output of 1, and for an input of 2, we obtain an output of 4. One quick note before we move on. Notice that the outputs of 4 and 1 are obtained twice, but that this table still represents a function, as it doesn't matter if any output values are repeated for separate inputs, as long as each individual input value only returns one specific output value. For the third case, a graph, I'm using a free online graphing calculator to maintain accuracy, to which I've provided a link in the description. In order to draw the graph on your own, you'll need to plot a few points before connecting them with a curve. That's where the table comes in. Notice that the ordered pairs on the table, or in other words, the x and y values that correspond to one another, are all present as points on the graph as well, which makes sense as both the table and the graph are representing the same function, y equals x squared. From a graph, it's easy to obtain both the domain and range of the function visually, so let's do it. Remember that the domain of the function represents the set of all allowed inputs, or x values. Looking at the graph, we can see that although the picture is cut off, it is going to continue to grow larger in both the positive and negative x directions, going off to infinity in both cases. Another way to look at it is to see if there would be any restrictions on the inputs of the function, or anything you know from algebra that would stop you from inputting any specific values of x into the equation. For example, we can't have negatives under square roots, nor a 0 on the denominator of a fraction. Looking at the function y equals x squared, we can see that there are no limitations on what we can plug in, and we can say that the domain of this function is all real numbers and can be expressed mathematically like so. All this means is that x can be any number between -infinity and infinity. We can also write the domain in interval notation like so. Remember that the parentheses indicate that a value is not included in the domain, as both -infinity and infinity are not numbers that we can actually plug into the function. Now for the range, which can be a little trickier to figure out than the domain. Remember that the range represents a set of all possible outputs of the function, or the y values that we can obtain. Looking at the graph, we can see that the lowest possible y value we can obtain is 0, and that the function will grow larger off to infinity in the positive y direction. We can express the range mathematically like so. All this means is that y can be any number between 0 and infinity. We can also express the range in interval notation like so. Notice that there is a bracket this time and not just parentheses, which means the value is included in our range, as the function can actually return an output of 0. Finally, we can represent a function with words. For our function, y equals x squared, something like the variable y can be represented as the square of the variable x works just fine. Although in our case, x and y are simply arbitrary, in real-world modeling, being able to verbally define a system by the variables that function within it is an essential part of effective communication.